So again, the easiest way to describe it is comparing it to traditional modeling. And traditional modeling, and this is more focused on river network or stream networks. Normally, what we have in traditional modeling is that the hydrologic component is fairly complex, and then we use the result from the hydrologic modeling and plug it into the hydraulic model. But most of the time, we're only interested on the peak discharges coming out of the hydrologic model. Now, what happens sometimes with this kind of modeling is that the hydrologic model needs input from the hydraulics model, because there may be hydraulic structures that influence the hydrology. And so there may be situations where we have to iterate between the hydrologic model and the hydraulic model. And and typically, the traditional way we do it is in steady state conditions. So link dynamic, and I guess it's tied, or closely tied to unsteady flow modeling. But the idea here is that we would have a very simple hydrologic modeling input, pretty much contained to only direct runoff calculations at a sub-basin level. And once we calculate runoff from the sub-basin, we just plug those results directly into the hydraulic model and let the hydraulic model take care of everything else regarding how water is going to flow through the system. Just a little bit about the software, and in some of the software packages available. If you're modeling stormwater systems, packages like StormCAD or XPSwim are in themselves, or have in themselves, some sort of a dynamic link they link dynamically the hydrology with the hydraulics. And in some of those computer software packages, they include a hydrologic component that is tied together to the hydraulics. Now, if you're dealing with a stream or river networks, at least here in the US, the HEC RAS is the one program that most of us use. In this case, the hydrology is not exactly tied directly to HEC RAS, but it could be through HEC-HMS.